My topic for today will be about video, but in previous lecture I skipped some important topic which could be important to understand better how video work is about lossy image compression, particularly with JPEG standard. And what is JPEG? JPEG is specialized compression standard, particularly for pixelated images or these bitmap images. And it is lossy standard because if you want to compress the image without loss of any information, you can use any archiver of your choice like zip, gzip, and 7z or whatever. But if you agree and you can get away with some loss of quality of the image, then you can compress image much better than these general purpose archivers. How JPEG works? It works in such way that first it uses some of standard compression approaches to remove redundancy of the image, but additionally it does following things, which is important regarding to our sight, how we see things. First is that most of these pictures, when you create pictures of real nature, from pixel to pixel, neither color nor brightness changes too much. So all these changes usually are quite gradual. So that means that if we can make some approach which considers these gradual changes from pixel to pixel and somehow removes these redundancies, it is good. And other thing is, particularly for our sight, is that what I told you in previous lecture, our resolution of sight is approximately 100 megapixels, but most of these are in center of our sight, and most of this resolution is just for brightness or grayscale pixels, and our sight to see differences in colors is much worse. So if you would look inside our eye and look on retina, then there would be many these cells which responds to grayscale or just brightness of the color, and then there would be different cells which responds to red, green and blue, only sparsely put in between. And that means that if we can compress this image even more by sacrificing colors a little bit more and brightness a little bit less, then we can achieve much better compression than general purpose compressors and archivers. And so how does JPEG works? First, it splits image into blocks, and these blocks are usually 8 by 8 pixels. Then it changes color schema from red, green, blue if it's for printed for display materials, or CMYK or CMYK or whatever you call it, for printed materials, into colors and brightness called luminosity, and other is I will tell you later. And then it does encoding using forward discrete cosine transformation. So what is important? It's not important if it's a cosine or sine or fast Fourier transformation, but all these transformations work in similar way. You change input signal into sum of different kind of waves. And I think cosine in this particular case is used because it has mirror symmetry, because sine function starts in following way, so it is not symmetric to vertical axis, but cosine starts in a following way, so it is symmetric regarding to left and right transformation, or if you put it by 90 degrees, it's also symmetric to top and bottom transformation. So first thing is it changes color space from red, green, blue to luminance and chrominance. Luminance is funny word for intensity of color, or how bright or dark it is, and chrominance is how colored it is. And because you need at least 3 different independent points, so for luminance is one axis, and for chrominance it is how bluish or how reddish it is. And greenish color then is calculated backward from difference between chrominance and luminance in following way. So why it's done in such way? Because then you can have more high priority for these luminance numbers, which represents how bright or dark picture is, and then you can do lower priority resolution and more compression, particularly for colors. And then instead of actually describing these pixels, they describe gradients or changes in these pixels using cosinus function. So you start with, if you have, let's say, some brightness in changes, let's say something like these vertical stripes here, then it means that in x direction there should be added a following wave which comes down once and comes up once, something like such wave here. Or if it's in vertical resolution, it in different way. So what it does, it represents this square of pixels, usually 8 by 8, not as all pixels together, but as a best approximation what wave function is best approximation between these gradient changes of color and brightness in this particular picture. And then here is possible patterns for these different kind of waves for 8 by 8 pixels, which is usually used. So if all 8 pixels are the same, so this means all this waviness for this particular area is 0, everything is in the same color. If there are some gradient changes, then this is this case, and if there are more wavy changes of either color, or then there are other cases. But what is important when you create such multiplication table of possibilities of changes, in most of cases, in 99, let's say in 90% of cases, how you actually describe this particular patch of image is this case. Then in remaining 9%, these changes are something like this, gradient either horizontally or vertically or diagonally, and then are smaller and smaller possibilities for these other things. And then what they do is, depending on what kind of quality you want for this picture, you either approximate everything with only this particular case, so you throw out every other possibilities how this pattern could look like. And by the way, it may be more complicated because here all the possibilities are with the same amplitude, but it may also be some sum of slower amplitudes together with smaller amount of smaller amplitudes. Or if you want to get better quality, then you describe this particular case, then these particular cases, and then everything else. So depending on this quality of these particular compressions, you create this multiplication table representing waviness for these patches, and then you apply weight ratio for it, and you round it up to integer numbers, and depending on what you actually decided as your quality check for these things, either you describe only these most frequent cases, or if you add more priority for these more tricky cases, then your compression ratio is worse, but your quality is better. And so instead of representing all these pixels, they represent only these different kind of cases, how these pixels can look like. And in most of cases, you can describe everything just in one or these few possibilities, what kind of pattern these pixels may have. And then you use a standard compression algorithm for JPEG. It is called I don't remember, but it's not so important. So then standard compression algorithms Huffman table is used for to represent these numbers, and then you can do it and compress it in different ways. So on each of actual picture is split into these 8x8 matrix points, and then it is described each these points in this zigzag matter starting from top left corner till to bottom right corner. And then when you describe it as numbers, they still apply this standard compression algorithm to compress these numbers a little bit more, and then you get with your compressed image with different quality. And what is important is that there may be different subsets of these JPEG images, sequential describing when you describe all these 8x8 pixels from top left corner till to bottom right corner. You may describe it as a progressive one, like first split it in larger pixels. So progressive description is following. Here is larger picture. You split everything 8x8 and you describe this in this zigzag manner. But with progressive ones, you actually choose first, let's say, divide by 2 of this and describe how this look using this digital cosinus transformation. And so you download this picture and you see very low resolution, something like some gradient of color here, gradient of color here, gradient of color here. Then it splits it by 2 and describes in more precise detail these pixels, and then divides by 2 until you are done with this particular thing. And also maybe using different likes, like hierarchical, you may start describing, for example, if you have some picture, you describe most important ones first, and then you describe everything else. And if you download it through the slow network, you may see how your browser actually fills up these gaps with more and more details. So that's what is important about compression of pictures. Any questions or comments so far? some oscillating or periodic things. If you have, let's say, only 24 frames per second, it's very frequent that you look on rotating wheels on cars. As they rotating things, they are moving either forward or backward a little bit much slower because of this strobo effect. If you have much more frames per second, then this not only switch from image to image is negligible, but also stroboscopic effect is much less visible. And much of this digital video inherited its features from analog information. For example, for these video players on magnetic tapes, these were still analog devices, so they recorded the signal as is without any digitalization. And of course, nowadays almost everything is digitalized because it has many advantages. First thing is that the digital source do not wear out during playing. It's easier to edit, and you can much easier access particular random place in your video. But of course, most of biggest drawback is that you need to have quite a large disk space to save these things. And first thing to do to get your video images, you need to have digital camera which digitalizes your picture and which digitalizes also your sound. And of course, now starting with GoPro, usually you have plenty enough resolution for your pictures. What still may not be enough is sensitivity in poor lighting conditions and blurriness for high-speed objects, but in general, all these devices are quite reachable for general public. And then and of course, if you do not care about quality so much, you care more about historical content, even video made with your mobile phone usually is good enough for home usage. So you start with some kind of digital camera, then you write all these digitalized pixels and sound into some video format on disk, and then you can replay it using different kind of devices depending on how smart this device is. Either it's general purpose computer or specialized player, of course this is up to you. And so how this digitalization works? It works, video is just advancement of photo. So you take bunch of still images and you digitalize each of these still images separately. And because of Moore's law is working everywhere where miniaturization can hold up. So if you can make everything smaller, then it can advance quite exponentially, and it is still happening also for resolution rates for video images. And starting with this Ultra HD or 4K, where I do not know what 4K means, usually you don't need much more resolution than that, because if you do not have screen for entire field of view, like you have immersed in virtual reality or whatever, but if you are looking on some large screen in front of you, then these approximately 6 megapixels of screen resolution is enough to you, because you don't see any difference at all, because your eyesight is not much better. But still, some bigger resolutions may be used just because then you can cut off particular parts of this image and quality is still good enough. And so, because of stroboscopic effects, also many of modern video formats usually use up to 60 frames per second, mostly because of fast-moving objects, to not see these as a sequence of separate objects, but to see they much more gradually moving around. But in most cases, usually you see somewhere around 24 or 30 frames per second, and in some cases you may see less. For example, for cartoons, it is usually maybe even twice as low. It may be upsampled to higher frames per second, but then you can see that, for example, 2 or even more frames in a sequence are actually not different at all. And of course, to save disk space, if you have like slideshow and screencasts, how to use computer, etc., you may use even less than 4 frames per second, for example, for slideshow. And now a little bit more about particular technologies. So first widely used digital video technology was DVD disc, and it has resolution for 720 by 480 dots. What is important here is that the dimensions of these dots are not the same in both directions. I think that width was bigger than height, and if your player or computer do not care about this aspect ratio, then you see this image stretched or more narrower in horizontal position, because physical resolution or physical aspect ratio is not 1:1. And then introduced MPG or MPEG video compression format, which uses these approaches to describe still images, similar to GPG, and also some advanced techniques which I will describe to you to compress data to remove redundancy between similar images which are in sequence during this movie. And particularly for sound, nothing very new, only Dolby Digital surround sound, so it has more than 2 channels. It has left, right, front, back and subwoofer channel, but in general it is just sampled audio, nothing very new there. And later Blu-ray discs were introduced with higher screen resolution, also uses MPG compression format, but with some more advanced techniques and with higher resolution. And if you have raw video images, then of course amount of data you need to store is huge, because you need to store still images for many times per second. And I think that on this table it still assumes that your actual still image or one frame is actually compressed using GPG standard. But if you don't use it at all, then of course your data goes out of the disk space pretty easily. So how can you deal with this? You deal with this using compression, and again, particularly for video, general purpose compression is not good fit, because if we allow to lose some of quality of this image, we can get much better compression ratio than for general purpose compressions. And one of brute force methods to save disk space is just use lower resolution and lose your lower frame rate, but in most of cases you actually use specialized compression and decompression. Why it's called codecs? So first, when you have your raw video data, you compress them and save it to disk or send through the network, and then these are decompressed to show actual data later if you read it from disk or if you read it from the network. And together this compression and decompression is called codec. And so standard rate, for example, for lossless compression is similar to standard compressors. General purpose compressors, it's something like 3 times, 4 times, maybe not more. But if you start using specialized compressors, analyzing actual internal structure of the picture and analyzing changes between picture to picture in video, then you can get 25 times better compression rate, 40 times, even 100 times better compression rate. And how do you do this? First, you can use different kinds of these coders or decoders or compressors and decompressions, and you remove different kind of redundancies. And again, similarly to compression of pictures, at the end, general purpose compression is used to remove any more redundancy, but before that, with good compressors, you use actual analysis of the picture and analysis of sequence of pictures to compress it much better than for general purpose compressors. And how do they do? First, they use space-related, called spatial, techniques to compress individual frames. So I told you general idea already. So you do not describe each pixel as an independent entity, but you describe groups of pictures with some good approximation, where good enough depends on your quality requirements and compression requirements. And then you apply these temporal or time-related methods to compress data in between times over time. So space-related is space in your two-dimensional space inside one particular picture, and time-related is how you describe them during time. And so spatial redundancy looks on this picture like one particular image, and it uses this GPG compression approach that large of this particular area may be described at just one single formula, something like everything is some kind of brownish reddish here, and that's it. And then, depending on your compression ratio and quality requirements, so here you can see worse or better approximation for these images. And one of things where GPG is not good compression standard is for text and logos and other things when you have sharp borders, because this transformation does some of harmonics, and if you have like change in brightness from 0 to 100 here, when you need to describe it as a sum of waves, you need, let's say, one slow wave here, then one faster wave here to increase and decrease, not so many, but let's say up, down, up, down here, and then more and more and more and more, and then more and more and more and more, and at the end you will get something like this. And that's and if you put them in one single dimension, what you see is here, instead of black, white and black, you see white, some lines of blackness, and then completely black. So these are these small peaks here. When you sum these harmonics of different these curves together. And of course, if it is two-dimensional, you have something like a black dot here, you have these artifacts here as these oscillations of this compression. Why these are not polar circles here? It's because of these borders of sampling here. Each of these borders have their own artifacts here, and therefore you have some kind of pattern around these sharp edges. But in most of cases you do not have these kind of problems, and you can live with these artifacts quite well. So that's about these pictures. Now, when you look on particular still frames of this video, you may see that actually there is also quite a lot of redundancy, not only inside the picture, but in between pictures during time. And so if you describe some of these frames or subframes in entire picture, you see that it is not changing much from the place to place. And again, these are described as vectors, as formulas for motion, to describe how this particular frame is moving during time. And you can describe it either as a lossless or lossy compression, and lossless of course is much worse than lossy, because then what do? You still describe it as a movement, but you describe as a frames, like adjustment frames, that because here maybe this rugby player is also rotating his head, that it not need to be only translated from there to there, but it also need to be stretched in or out, so some kind of another transformation should be needed. And these other transformations are applied as additional rules how this particular subframe should be translated. And so what do? They describe some of these images as a complete picture called keyframes. And in MPG standard, these are called iframes, from, I will tell you later. And then everything else is described as difference frames, as a difference from this picture and next picture. And similarly to graphical pictures, because our sight is more sensitive to changes in brightness, not so sensitive in changes of colors, all these changes in translations are described not in RGB schema, but in luminance and chrominance schema, because luminance is more important, that is brightness, and chrominance is less important because these are colors. So then you describe some of these frames, and then you describe some other frame as a sum out of it. And what kind of different frames you may have? You may have different ones. You may have moved camera. You may have moved object. You may have illumination changes. You may have scenes cut. You may have noise, of course, and other things. And for example, here you can see two pictures for comparison, that almost nothing is changing between these ones. Only here some frames are moving on here, and then entire scene or entire all other pictures are just moving because of changes of camera angle. And so you can describe these motions as a panorama changes in camera. Something new comes in one direction and something old comes out of this camera view. There may be rotation, something like spinning or rotating. There may be moving, and there may be zooming in or zooming out. So this means some of these objects may become larger or smaller. And so here there are some of cases. For example, in one particular frame you have objects in the following way, in another like here, and you can describe it like as rotation or zoom or whatever. And so you describe these motions as vectors or the numbers, how these should be moved or rotated or any other transformation. And then, particularly for lossless compression, you may also need to add frames which are called motion compensation. What is motion compensation? So you approximate some of your frames with movement, but when you compare constructed result with actual result for next frame, you see that there are some differences, because there is not only movement but there is also rotation, or maybe it's not only movement but also zooming in or zooming out. So you add particular frames which marks also differences which need to be applied as a patches to constructed result. For example, here we need to change frame from such pictures to such pictures. You can add compensation frame, like subtract value from here to that one and subtract to that one. So something like second order of approximation. First you describe something as a movement or rotation or whatever, and then you add patches with these compensation frames to adjust this picture a little bit better. If you are okay with lossy compression, then you don't need to apply these compensation frames. If you want to get lossless compression, then you always need to add these compensated frames, because all these algorithms what I described to you, of course they do not describe change from one particular still frame to another absolutely correctly. And then particularly for different kind of compressions, you can describe these things in different ways. You can describe in forward predicted blocks. That means you describe it as a changes from previous block to the next block. But you can also describe it as a backward predicted blocks or interpolated blocks. This means somewhere in between. So why it's important? Because I think I will have some example later, but if I do not have, it's also about camera, panorama set, etc. For example, if you see in camera, what's that? This field of view and camera is moving, so here will appear something what is not here yet, but will come visible when camera will be here. And if you describe all these changes just as addition or differences from previous one, then these objects which suddenly come into camera are quite hard to describe, because they show very large differences from previous frame. But if you describe it as a forward-looking frame, and you see on this particular object which is fully visible here, then you can describe some of this part of this visible here only as a part of this frame moving gradually from this particular frame in this time to here. So you get better compression ratios there. What is not so good here is that you can apply such backward looking frames or frames borrowing data from frames into future only to replay this from disk or DVD or whatever, because you know how to look here in the future. If that would be, for example, streamed network and you are talking to somebody with video conference, it can be doable, but you still need to look into future. This means what you will see as an actual picture of your conversation partner will be delayed by this amount of time while your replayer, or player in short, needs to look into future to do these things. So because of that, in streaming encoders or codecs, usually you do not do this trick, and because of that, streaming coders are always a little bit worse in terms of compression ratio, because they never look into future. They always say changes from the already known data, from this data which you already downloaded from network or whatever. So no more details about this MPG or MPEG or whatever format you call. So it uses all these approaches to compress video, what I told you before, and usual compression ratio for good quality MPG is approximately 40 times better than raw images. And so it has borrowed quite a lot of things from compression of JPG images. It usually uses 8x8 blocks, which may be put together into groups of blocks to describe it as a group. And then it can sacrifice more or less data about colors. So it may be that the blocks of colors and block of brightness is the same, like 4 blocks, 4 blocks and 4 blocks. That means brightness, blue color and red color as a this chrominance, but it may be also that 4 blocks of luminance and only 2 blocks of colors, or even maybe 4 blocks of brightness and only 1 block of red and 1 block of blue color. So, and then these smaller 8x8 blocks may be put together into macro blocks, and then they may be described as these groups of pictures moving somewhere around. And then they use a little bit different wording than I told you before, how they describe these frames. First, these frames, which in theory usually are called keyframes or still frames, which describe entire picture from border till to border, they call intra frames for some reason, or E-frames in short. So E-frames describes entire picture, what you see as one still image entirely. Then they use so-called P-frames or predicted frames, and these frames are described as differences from one of previous E-frames or keyframes. So it means they apply these all motion vectors like translation, rotation and zoom of these groups of objects to describe some of these pictures from the previous ones. And then they call these other frames, which are describing other differences from next frames, not previous frames, which is useful for newly appearing objects into particular frame as B-frames or bidirectional frames. So these are full still frames. These are frames P-frames are frames described as changes from previous ones, and B-frames are described as a frame differences from the next ones. And here is this example about this new object coming, which was not visible here, but become visible here. So these objects are moving inside this mouth of Pac-Man. And if it is described as a p-frame, then you need to create entire new object as a quite big difference. But if you describe it as a just translation movement of object which is not visible yet but will become visible in this particular iframe, then you can do it just as a translation for this frame to that frame here. And so B-frames are used mostly in recorded media because player may look into future and put future into buffer and then reuse it. But these B-frames are frames describing changes from next pictures are mostly not used in streaming media because you do not know future yet. And if you would know, then of course it needs to be put in buffer. This means you will have bigger latency, so it's not good for simultaneous conversations. And then, depending on different kind of compressions approaches, knowing that each of them has their benefits and drawbacks, they may describe this stream of data in different ways. For example, standard is one iframe, then some of B-frames, P-frames, etc. So everything is mixed, and this mixed approach is much the best way to describe like a recorded movie. But they can use different ways, like everything is just iframe, all these keyframes. So then if it's compressed in a such way that each of these pictures are absolutely independent, so you can cut and put together your video in any place without any recalculations. Mixing together iframes, B-frames and P-frames are these forward and bidirectional. These are used for recorded movies. Forward predicted only, which actually means difference from previous frame to next, is usually used for streamed media. And about this format I don't know. So, about video editing. You get some kind of analog, or in most of cases today already digital source. Then you may need good enough equipment to read, write these data and edit them, and then you control. So what you can do, that's not good. Sorry for interruption. I don't like these things. So what you can usually do, of course you can make your own movie, fully featured movie, like science fiction or documentary or whatever. But usually what you need to do is to cut and mix different kind of tracks together. In general, these are called clippings or clips. So you have different sequences of your data, like different tapes or these films together, and then you need to assemble them in some proper order, how you like to show your movie to everybody else. Then you can do different kind of transformations, transitions, and changes from screen to screen. Then you can add different kind of digital effects, and then you do different kind of additional composing, like add keyframes, add titles, etc. For example, here you have some image of nature. Here you have some picture of plane, and then you can put, for example, that plane is moving on the background of nature. And now, when more and more movies are digitalized, for example, for most of fiction movies, they film most of these things on so-called behind green screen. So because actors are still a little bit better than animated characters to show their expressions, etc. And then after this green screen is done, so here is your actor performing on green screen. You put everything behind it, what you want to do according to your requirements for your fiction. I will not go into details about this. You use so-called masks here, similarly as masks for still images, what you did for your previous exercise. Only difference is that this mask should be moved around to put many still images together. And now what is important is to remember about compression formats and about removed redundancy. So if you are editing some video which do not have all frames as a keyframes or iframes in MPG standard, then you can cut something and you have missing data to restore these particular frames or subframes of your image, because you lost some of these previous frames, and here some parts is described as a change from previous frame, but because you cut this previous frame off, you do not have any data there. And then when these are propagating through, you have more and more data. You see these moving around images, and this is nice thing to see how these translations work here. And if you look carefully here, you can see also this digital cosinus transformation actually described here. You see here that these are described as horizontal stripes, changing here and here something like vertical stripes. So these are all artifacts because of still image compression and because of this temporal compression between frames to frames. So this is one of typical examples that you can see how things work better when they are actually broken, because if everything is fine, you don't see how it actually works, but if something is broken, you can actually see how it works. Does anybody want to ask something? So that's about these things, and in practical exercise maybe I will try to demonstrate it. It's not so easy, but you need to remember about that. And then other thing what you need to consider is about sound for movies. In general, 44.1 kHz sampling rate is enough for CD quality, DVD quality, etc. And higher sampling rate is not necessary. You will not see here, in this case, here any difference in proper double-blind A/B testing. And of course it needs to have at least 16 bits for dynamic range or this value resolution, but that's enough. But you may see higher sampling rates and you may think, okay, it's just because it's better. No, it's not because it's better, but because it's easier. And why it's easier? For example, standard frame rate for like analog movies, etc. is 24 frames per second. And if you do simple calculation, you see here that for each 1037 frames, you need to add half a frame, or ratio is not an integer number. So that means that every time you will have 1837 pictures, you will need to add one more frame, or in this case sound sample for sound. And what they do, they usually actually just smear out this remaining part, and they sometimes add one of needed sound samples just to make it working. And of course it is I will try to demonstrate it to you in practical example. What is happening is that when you do this editing, this means that your sound track and video track, when you edit them, they shrink and become bigger, not at equal rate, because you can't cut and put together it in any place, because this rate between sound samples and video samples is not a precise integer. But if you, for example, use 48 kilohertz and you divide it by 24, you get precise number. If you use 84 kilohertz and you use 30, you still get the same. If you, I do not know about this one. But the good thing is that, and also if you divide it by 25, it still is precise number. And that's why, particularly for digital video, they usually use 48 kilohertz sampling rate, because it is easily dividable for all these different frame rates for images. So editing is much easier. You will never get such remaining part that your samples for audio and video tracks do not match precisely. So synchronization between sound and video is much easier, etc. And what kind of editing software you can use? Of course, if you do not care about your freedom and you are happy using stolen or illegal copies of Adobe products, then probably Adobe Premiere Elements or Premiere Professional is good, or Adobe Final Cut Express or Professional. And there may be other companies like Colorel has, Apple has, etc. But for open source world, probably the richest editor is called Blender. But it is quite learning curve to start using it, and I do not know how well it is supported for Microsoft Windows, MacOS, other systems. Then there is OpenShot, KDE and Lie. So K comes from KDE desktop environment, and using that graphical framework they also use. PTV is quite easy to use. There is also an editor called Cinderella, and initially it was Cinderella CV from community version, but then it was not advancing at necessary rate, and fork was created called Cinderella GG, where G comes from, I do not know, global, I do not know. And for example, for Microsoft Windows, there is an open source editor called VirtualDub or VirtualDub. But again, it was not developed recently, so another fork of it was created called VirtualDub mod or modification. And there may be a bunch of other editors, you can look about them here in Wikipedia and analyze them and decide which particular editor you could use. And then about file formats, as usual, in my classes you can use any tool you like, or you can use, hopefully legally, but what is requirement is that you have to generate appropriate format of video file. And here is general overview what are currently used video format files and what you should use. So probably if you want to work with open source tools and the most open video formats as a file, then OGV from Open Group Video, I think, comes this OGV format, and the format itself is called OGG, and there is some video game where OGGing is some particular operation, I don't know. But and then this is a container format, and containers describe how you mix together audio and video tracks into one single file. And as I told you, in theory you may use any container with any codec, that means compressor decompressor format, for audio and video tracks. But in practice, of course, there are correlation how editors and how players are using them. And the most friendly format for this OGV format is Theora format for video compression, and FLAC and Vorbis for audio. So FLAC is lossless compression and Vorbis is lossing compression. Then MKV coming from Matryoshka container format. Again, in theory, you can put any codecs inside it because container describes how you mix audio and video together, but usually you have mostly MPG with MP3 or whatever formats put into MKV. Then there are different versions of MPG. If file extension is MPG or MPEG, then probability is very high that this is older version of MPG standard, like version 1 or version 2. And these version 1, version 2 are used for video CD and DVD discs. But if you use it as a streaming media or save it as a file, usually you will have extension MP4, which says that it is MPG version 4, which is the most recent and most modern one for compression. It is usually used, for example, to save internally for YouTube, for different kind of mobile devices, etc. Then there are MOV format for QuickTime video player. You shouldn't use this anymore because it's outdated. AVI format, which could be considered outdated, but one thing about AVI format is that it allows you to use lossless compression using only E and or P frames. That means keyframes and frames which describes next frame only from previous frame. So this, if you describe everything as E frame, is the best format for video editing, because you can cut and paste your your video in any place, and replay will be always good, because when you will compress it, you will have all needed data to start compression from any particular frame. And then one of other modern standards is H264, which is current standard to play video inside web browsers. For example, if you use different kind of streamings, etc., it may happen that you use H264 internally as a compression format for actually for streaming. And then there is Adobe Flash format, you shouldn't use it anymore. Then is Windows Media Player files, and you shouldn't use these anymore. So these are different kind of options you can use, and particularly for your practical exercise, what will be required that you provide your video in this OGV format. Any questions or comments so far? In your practical exercise, you have to create video file, which is only 60 seconds long. And only trick is to provide required output format, because depending on tool which you are using, it may be harder or easier to do. And first thing you need to have some video file prepared. And I have prepared this video, which is, I think, from is 24 day down here, and it is in MP4 format. And what we can do, we can just open it directly in some kind of video editor. An easiest video editor for simple cutting clips and putting together in Linux operating system, I think it is editor called KDA Enlive. So you insert clips, what is I think drag and drop. How can I go up? So I think this editor allows us to do it in the following way. And then here is some preview window, and as usual these more modern editors are not intended for small screen resolution. How can I move it up? Maybe here, yeah. So it has some empty tracks already prepared, you put it something like video 1, audio 1, and you can play it. So, and for example, my topic especially is cut off some of parts because some people like I skip these places, like initial garbage. I do not allow it. I want to see cut that is a head. Maybe the resolution is too small. But I don't see what I want to see here. Some split it. And then you can remove some part. Split only. Put everything, for example, here, and check where is 1 minute. Let's say somewhere here. Remove everything and you can play something frames you may have is this compensation frames, and then you have to process it, because here what I have done, everything is just in buffer. So not really created. You do so-called thing called rendering, and here you choose some formats on KDA and live. I think maybe it's not supporting OGV directly. What can you do? You can use, for example, MP4. And you render it. And that may take quite a lot of time. Then what is also important is that here, to be safe, I actually have recorded more than 1024 by 768, but something more, I need to do crop or cut some of these unneeded parts of this video away. But in this particular editor, I don't know how to do it. And therefore, I will show you some other editor. Editor I'm recently using is editor called Cinelerra GG, and it is fork of previous version of editor called Cinelerra CV, because it still is developed, but not so quickly than this fork. It's something like LibreOffice is fork of OpenOffice, and OpenOffice is quite dead now, and everybody is using LibreOffice. And similarly here about these editors. And as far as I know, it works only for Linux, so therefore I will show you only as an illustration. But if you decide to use it, then of course you can use it. And for example here, if you produce like MP4 format or whatever, then one of your tasks is to convert this to required OGV format. And there are different kind of tools you can use, like FFmpeg, it's command line tool. There may be two different extensions for these OG video files, because format is actually called OGG. And if it compresses only audio, it may be called OGA from OGG audio or OGG video. And then the leading standard for command line utility is utility called FFmpeg, and you do something like this. First check our video file. So here it is. Some of it which could be important to understand better how video work is about lossy image compression, particularly will. And then I open it to current folder. Here is our sample. Input actually is untitled MP4. And we convert it. And here it shows what is speed up from real time. So if I created video for 1 minute, and it is approximately 5 times faster than for real reply time, it means I need to wait approximately 12 seconds, if I am correct. Okay, let's check some of import which could be. And here all these needed parameters what are required for you to have here. You can add for this conversion tool, for example, screen resolution, sample rate. These are just additional parameters here in this FFmpeg or FFmpeg tool. Codec for video, codec for audio, and then different parameters. What can you do? You can and here, for example, you search for how to set screen resolution, how to set frame rate, and similar things. So that is one of options you may use, and FFmpeg is not the only one. There is also utility called Mencoder. There is also other utilities. Maybe something is, I don't remember. Here I have a receipt in video tools. What you can do. So this is my public notepad when I have done some of conversions, but leading ones are these FFmpeg and Mencoder, particularly to convert to this OGV or TR format. You can use also such utility and other utilities. Now what we can do, it will not be checked very carefully, but if you want to do more professional video editing, you need to care about these keyframes, because if you do not care about them, let's check it out, how it starts, which it starts pretty well. So this means there are no missing keyframes in this particular cut when I cut off some of the beginning of this file. But if I'm not careful, it may happen that you start your video with either a blank screen or these moving artifacts around, because you do not have your video starting with keyframe, which is iframe in MPG for standard. And I will try to show you how it may look like with other editor what I'm using more frequently. So other editor what I'm using more frequently is called Cinelera. So name as usual for open source projects is quite hard to say. I will try to make it fit into the shared window. And again, it has some of empty tracks already created. You may add some files. And initially I will This is, I think, that initial file, and I will say replace current project. So I have recorded 2 audio tracks. I don't need one. And here I need to change format, not to 1033, but 2024 by 768. Or extended, and here sample rate not this one, but this one, and channel is only 1. I think that's what we should do. And then I need just 1 minute. Here again. Let's look here where it starts. How can I do it in shared small window? I can make this even smaller. Not that one, but so again we need to remove some garbage from the beginning. Let's say somewhere here. Would be important to understand. Okay, let's. So here we can say put marker, which is bracket here, square bracket. Put marker here and delete that one. And then we go till to 1 minute. There is 1 minute. This is already 2 minutes. That's somewhere here. Okay, will be good enough to me. And you'll see here that because I'm using strange sample rate between video format and audio format, I cannot cut audio and video in precisely the same place. And that's why they use this 48 kilohertz of sampling rate, because if you do many cuts and joins, you will always need to adjust a little bit particular track here, because it cannot be cut precisely. Audio track cannot be cut in precisely the same place as video track. And so what can I do? So 1 minute is approximately where? Somewhere here. And in this case, I got lucky because now both tracks actually can be split in more or less the same place. And it's still 1 second more than needed. And if I will cut it somewhere else, probably it may not be cut in the same place. And now I will not save it, I just render it. Then other thing is, here I already set that format for my file is as required, 1024 by 768. But because my initial recording was with larger screen area, what actually may be needed here is to adjust this camera view where exactly I want to show, for example, to cut off these unneeded areas at the beginning. So I can adjust at the very beginning of the video here that I will see something like this part. So this is this camera panoramic view, which you may adjust if you need or if you like. And then let's check some settings. Sample rate for audio is correct. Then we can render it, and particularly for Cinelera it is very easy. It already allows you to use OGG format, or this OGG container format with Theora and Vorbis. This is for video compression, this is for audio compression directly. And because there's no actual requirements about quality here, only screen resolution, sampling rate, etc. So you may accept default settings provided to you and you render it. And now let's check our result. It was this one. Could be again I got lucky here. There are keyframes already there, so it doesn't look very bad here. But this movement of camera angles is not actually at the very beginning, so it should be adjusted. But particularly for these edits, if you do not want to be sure that there are no these artifacts from compression, that you have deleted some keyframes, particularly for Cinelera, there is setting here, generate keyframes while tweaking. This means every time I cut something off, for example here, new keyframe is actually created here at the beginning of this track, that it starts properly from that place. And I do not know what is keyframe spanning here. But by default I think it is not switched on, so you need to be careful that it is done. Other option, what you may do is you create completely different video format. What I did here, I wanted to exit. You may create a video which actually consists only of keyframes, and you can do it here from this receipt about Cinelera, because that's what actually developers and maintainers of Cinelera are recommending for you to do. So here they use this mencoder command line utility, and what it does, it converts any input format to AVI output format, where each of these frames is actually keyframe or E-frame in MPG standard. So you copy it, of course your current folder in command line should be as current folder of this editor, and you do something like this. So input file for me will be this one. And this one. And it will take quite a lot of time to convert it from that format to that format. But because all of these frames are independent, I will just wait for some time. You shouldn't do this, of course, in real life I will just pressing Ctrl C, I forcefully interrupted it. And for example, here is 1 hour and 14 minutes of video, and it takes 77 megabytes. Here so mine it is only 10 minutes created for video, and it is 333 megabytes. So it's still compressed, it still uses compression for still images, like as for photo pictures, but all of these frames are keyframes inside this video. And then you can use any editor and you can cut it. Oops. In any place, and you will never have problems with these keyframes here, because all of these frames you see here are keyframes, and then you will never have these initial artifacts happening when you start between cut and cut here in these videos. So that's other thing you need to remember about. And of course it depends on what kind of editor you are using, what kind of approaches, and you will not be penalized if at the beginning of your video here you will have some of these compression artifacts happening, but of course if you want to do it more or less as a amateur professional, then of course you should care about this. Other thing what you need to care if you have to do some video editing in real life is synchronization between audio and video. And if you are not careful, it may be hard. For example, if audio and video is not dividing very easily when you just cut and paste some places. For example, if this sampling rate is not good, you cut some place here out and you go to end of your tracks and you see that audio tracks or video tracks are shorter than other one. So that means because you have this division rounding problem, it may happen that you are not allowed to cut audio track and video in the same position in the time because of different and not compatible sampling rates. And question may be how precise you need to be between audio and video. Answer is that difference could be approximately 10 milliseconds, but in one direction it may be more than in other. Why this works in such way? So here is a real life situation. You are standing here and Big Bang is happening here. And here is, let's say, I don't know, 30 meters. What you will see, first you will see light coming, because speed of light is in air approximately 300,000 kilometers per second. It will take, these are meters, so that would be 300,000. Let's say it happened immediately. Then sound will travel to you, and speed of sound is only approximately 300 meters per second in air. And for 30 meters it says it will be 30 divided by 300 is 10, I think it's 0.1 second. And then, depending on what kind of solid you will have here, maybe some vibration through the ground is also going to your feet. And then through your feet, through your body, you will also feel vibration. And just for make it more interesting, let's say it will happen after 0.3 seconds. So, and if you look on time axis here, let's say, okay, time flows in the same direction as events happening. First you will see light, then after a few milliseconds sound, then after a few milliseconds vibration. And what is actually also important is speed of signal inside our nerves into our central nervous system. And because legs are much longer than ears here, it will take, let's say, 0.1 second. And what is happening, what I already told you, is that if you just move your eyes briefly to some place and your eyes are actually still wobbling and you don't see exact picture, brains are filtering it out just as a noise, and when you get a real picture, they actually fakes your memories about past, and it says this subconscious part of your brain says to conscious part of the brain that what you saw in past was this picture, so it actually fakes past. And also similarly here, you see, feel, and hear different events here with some differences in during time, but here all these events are written into buffer of your memory, and then it is waiting for few milliseconds, and then if it reprocesses it and see, oh, here was light, here was sound, and here was vibration, it says to your conscious memory that everything was actually happening in the same time. So actually it writes all these events in buffery, but do not show to you. And when it reprocesses it, then it says everything happened at that time simultaneously. And because sound is slower than light, usually if you see some difference and so sound is behind picture, everything seems okay to you, because we always adjust these events, because what we see as the most movement of our partner of conversation, etc. Actually, what we see is not simultaneous to what we hear. And because of these fake memories or fake past, what is happening here, again, our reaction time is actually much slower than we think, because we feel that everything happened simultaneously, but that's what internal part of our brain says to our consciousness. And therefore, if your sound is few tens of milliseconds behind picture, it still is feeling okay. If sound is before video, then it is abnormal situation in our everyday life. Then we will catch this problem with synchronization much quicker, because that's what we have not used to feel and see. And what can we do about this? If you will look on professional videos, you will see some talking head, like in news event or whatever. So one time you see something like this, blah blah blah, blah blah blah, blah blah blah, and then it's cut, and you see it from completely different position, talking figure here, blah blah blah, blah blah blah, blah blah blah. So every time these editors have a problem between synchronization, for example, they want to remove e's and ahs and whatnot, all these visual words. So they want to make this talk actually better than it actually is, so you can catch that what this blah 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 is doing here is actually not what is said here. They make this not close plan but remote plan for this, that you can't catch this mismatch between picture and sound so easy. And of course in some situations you actually see this blah 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 happening from behind. So we see interviewer here. So interviewer is listening and this guy is saying blah blah blah. So that definitely is case when picture is actually not synchronized with actual sound. So that are some of tricks you should know for real life editing. And that's for your future. It's not but if of course you will make this record of you doing something, talking, etc., then of course it may be important for you for this practical exercise as well. And because of that, probably you know why these professional movie makers, etc., they clap with their hands or do specific these movie cases like double 13 movie blah blah blah, and clap it, because that is good way when you can synchronize picture with sound. So every time you see some kind of event, you can check, so when this device was closed or somebody clapped with his or her hands, then this clap should be also in the same place in sound track as well. And so that's about this video. So you make it. I already showed it how you make. I showed also this one. And in short, that's it. Do you have any questions, comments? Do I need to show you how to try to do this in Windows, or you will manage it by yourself?